ahead and get started. Hello, everyone. Welcome to the Virtual Engineering Seminar. Thank you all so much for being here. My name is Mariah Manzano. I am a senior web design and engineering major and the president of the Society of Women Engineers, or SWE. A few house rules to keep in mind throughout the day. Please keep your video and microphone off, but the chat room is open. If you have questions at all throughout the event, feel free to throw them in there. So before we dive in, I just want to go over the schedule very briefly today. My friend Taryn is going to throw it into the chat room. We're going to start with an introduction from Dr. Wilson. Then we'll hop into our faculty panel Q&A. We have some incredible student volunteers with us today. They'll introduce themselves, and from there we'll go into our breakout panels, and then we'll come back for a few closing remarks. And so with that, let's get to it. I'm happy to introduce our Acting Associate Dean for Undergrad Engineering and Electrical Engineering Professor, Dr. Katie Wilson.
Okay, thank you, Mariah. I'm going to share my screen and I'm going to show some overheads. And let me view. Can everybody see my overheads?
Yes, that looks good.
All right, so this is me. I'm a professor of electrical engineering. That means I have lots of spark. And so frequently asked questions. What is engineering? What does the future hold for engineers? How do I know if engineering is for me? Well, we'll talk. I'm going to talk very fast within 5 minutes about what is engineering. And engineering, there will always be a use for engineers. We have had engineers since the person invented the wheel, and probably before that when they invented the club and the whatever. So engineers have been around for a while and they're here. And one of the things that's great is the fact that you're here means that engineering is probably for you because you're curious about it, and that's a lot of it. So this is taken from the National Academy of Engineering, and that's sort of the big organization for engineers. And it's the application of science, and we take abstract ideas and build tangible products. And engineers are men and women who create new products and products that didn't exist before. We change the way people live, right? We come up with things like Zoom so that we can communicate in a time like this, and it was engineers who built it. So, are you an engineer? All right, do you like to make things? Do you like to cook? Do you like to sew? Do you like to garden? Work with skateboards? Play with your, tinker with your bicycle? All those things and many more. That's engineering. How you think about things, how you think about putting things together. Do you like math and science? Do you like to solve puzzles? And do you want to point to something in the future and say, I helped build that? That's part of being an engineer and part of the wonderfulness of it. So this is a very short list. It's alphabetical order. Types of engineers. There's a gazillion types of engineers. Aerospace, agriculture, architecture. See, I'm going in alphabetical order, ending with electrical, but there's also mechanical. Anything you can think of that you can build, you can have an engineer like that. There's textile engineers. One of our students has just gone off to do a PhD in textile engineering. It's very cool. So the world is wide open in that sense. Things engineers make, well, planes. I think that would be an Airbus because that's Air France. Skyscrapers, computers, the hardware that goes in it, cars. Cars take mechanical engineers, vehicular engineers, electrical engineers, computer engineers, you name it, it's in the car. And printed circuit boards, just about, if you're talking with us right now, you're using a printed circuit board to do that. Biomedical engineering, prosthetic devices. Your iPhone takes a bunch of engineering, the glass behind it, the mechanics behind it, the electrical engineering, the systems work, the software, and even sewage engineering. That is a type of engineer. One of my best friends at Santa Clara was the sewage guy here, so that was very cool. And it's necessary and important. So if you were to come to Santa Clara University, this is a pie chart of what the engineering curriculum looks like. So discipline specific. So if you were to major in electrical engineering, about 37 to 38% of this purple part, that's the purple part, would be your major. And this blue part of the pie would be math and science. But also, and then there's an engineering core. There's courses that all engineers should have. A little bit here with free electives. And then what's really cool is this big red part, which is humanities. Because SCU, and other engineering schools too, but SCU in particular, cares about what's called the T model of engineering education. So we have the deep core skills, math, science, engineering, but we also have the soft skills. It's a funny term, but it means that it's really important to be able to communicate. If you can't explain what your product is about or your project, it's not going to catch on. And the ethics and integrity of it. We want people with an entrepreneurial mindset, creativity, and a global view of things. How does what I do impact the world? How does it impact the society around me? So one of the things we're really proud of at SCU is that we are educating engineers to understand the difference between private interest and public good. Especially in these days, it's so important to have that. And we want new technology that's critical to improving life. So that's my whirlwind introduction to the world of engineering. I'm a communications engineer, so I've worked on Wi-Fi and cell phones and things like that. And it makes me really happy to think that a little bit of what I did has gone into making it possible for us to meet remotely. So with that, I'm going to hand it back over to Mariah.
Thank you very much, Dr. Wilson. Alrighty, so before we move on to the faculty panel, I first want to introduce my friend Taryn. She's one of our incredible student volunteers with us today. So Taryn, can you introduce yourself, maybe your name, major, and your role today?
Yeah, so hi, I'm Taryn. I'm a first year studying civil engineering, and my role here today is monitoring the chat. So if you guys have any questions as we go into this faculty panel, please ask them all in the chat. We'll try to get as many as possible answered. These can be directly relating to what they're already talking about or just anything you have in mind. So please add them all in there and we'll try to get to them as much as we can.
Yes, thank you, Taryn. So just to echo that, please feel free to throw any questions you may have in the chat and we'll get to as many as we can. And with that, I'd love to introduce some of our faculty. So we have 6 faculty with us today, all from different departments. It's always good to start with some introductions. So as I say your name, if you could tell the audience a little bit about who you are, that would be great. So let's start with Dr. Mobed Miramati.
Hi, my name is Miriam Mobed Miramati. I've been at SCU for the past 7 years. Prior to that, I taught at SJSU, and prior to that, I was in the biomedical industry for 12 years. I have experience in diagnostics, genomics, and biomedical devices. I grew up, I was born in Iran. I grew up in Canada, and I did all my studies at McGill University, Canada. And I teach graduate and undergraduate courses at Santa Clara University. And what I like the most at Santa Clara is the diversity of the students and the compassion and the expertise of my colleagues. That's it for me.
Awesome. Thank you. Up next, we have Dr. T.
Hello, my name is Tanya Nilsson, and I'm in the Civil, Environmental, and Sustainable Engineering Department. Hey, Taryn. So I am a structural engineer is my training. So prior to getting into academia, I actually worked on buildings and bridges and even rock climbing gyms, and which is a passion of mine. So, but I love teaching and I love helping the next generation come on into engineering. And so it's just been a joy to be at Santa Clara because it's definitely different here with the T model and the humanities brought in. So I'm excited to invite all of you to explore engineering.
Thank you, Dr. T. Next up is Dr. Anastasiou.
Hello, everybody. My name is David Anastasiou. I'm a professor in the Computer Science and Engineering Department, assistant professor. This is my first year actually at Santa Clara University. I taught at San Jose State University for 3 years before that. And before that, I was getting my PhD. Before that, I was working in the industry for a while as a systems engineer. I love engineering, specifically computer engineering. That's my passion. Specifically, a little more specifically, I love working with data. So I work with machine learning and data mining. I do a lot of analytics, but more importantly, I design new algorithms to solve data-related problems. And find new solutions or faster solutions for those problems. Thank you.
Awesome. Thank you. And then next is Dr. Wolf.
Hi, I'm Andy Wolf. I'm with the Electrical and Computer Engineering Department. I started my teaching career at Princeton, and about 20 some years ago came out to Silicon Valley to join industry. I designed chips for PCs for 3D gaming, and then later audio and video products, some of the first digital audio video products. About 7 years ago, I came back teaching here at Santa Clara, where I teach a sequence of classes about designing and building devices using computing technology, electronics technology, communication technology, and putting that all together to build things.
Cool. Thank you very much. Next is Dr. Jack.
Hey everyone. My name is Jess Kaczynski. Since Kaczynski is kind of hard to spell and pronounce, most of the students call me Dr. Jack. I am actually a chemical engineer. We don't even have chemical engineering at SCU, but my focus was always on thermodynamics and engineering design. And so I'm the director of general engineer here at Santa Clara, and my focus is on engineering design and how that intersection between engineering and its impact on society, so things like its intersection with business and entrepreneurship. I teach the freshman class, the Intro to Engineering course. So Taryn is in one of my classes right now. I teach a prototyping class over in the Maker Lab. I teach community-based design, where we actually go out into the real world and impact our local community with our engineering skills, and then all the way up through senior capstone. And so I've got a wide range of experience. This is the 5th institution I've taught at, and I've been at Santa Clara for the past 6 years. And I've taught everything from community college all the way up to big R1 institutions. So I have a lot of experience if you have any questions about any of that.
Awesome. Thank you, Dr. Jack. And lastly, Dr. Pak.
Hi everyone, my name is Anshun Pak and I'm in mechanical engineering. It has been 6 years at Santa Clara, and I really enjoy the small school environment at Santa Clara because we get to interact a lot with students. That's what I really appreciate. And my specialization is in flow mechanics, which include the study of blood flow in our body to the flying or aircraft in the air. So, and my research is specialized in the study of swimming microorganisms like bacteria, sperm cells, things like that. And we are trying to design robotic micro swimmers that can swim like them for biomedical applications. So I look forward to talking with you guys more.
Cool. Thank you. So let's go ahead and dive in. These questions are for anyone, so feel free to jump in if you're interested in answering. And a reminder to all of the students, if you have any questions, feel free to throw them in the chat. So first question, how did you know that engineering was the right path for you?
I'll say I didn't. It was somebody who knew I enjoyed math and science, but I had this creative streak and I didn't know how to combine the two together. And so I got turned on to engineering. And you know, there were times along the way where I wasn't sure if it was right for me, but I'm so grateful that I did it because you learn in engineering school how to be a real problem solver. And it doesn't matter if you stay in engineering or take that degree and move sideways, that having that problem solving skill and that critical thinking that you learn during an engineering degree ends up being a value added bonus to anything. You can go into business and be really successful with an engineering degree, but you can't get a business degree and then go into business. And so that critical solving, and then it turned out that as an engineer, and I had no idea, I got to design and build things that helped people's lives. I mean, civil engineers make inside possible. You're welcome. you know? So it was really cool that I could make earthquake safe buildings.
I'll jump in. So I also, at least my senior year in high school, I did not know what I wanted to do. At first college I visited, I was to go to photography school. And then I thought maybe I wanted to be a pre-med. But I always really liked building things. And when I was a kid, there was a cartoon on that I used to watch called The Jetsons that had people who lived in the future. And there was all this stuff. There were TVs on the wall and you could talk into your wrist, right? And there was a box you could talk to and it would answer your questions, right? I just knew that stuff was going to happen in the world and I wanted to be part of it. Now, those things we have today, but think of all the things we don't have. An artificial kidney, right? Or real self-driving cars. If you're the kind of person who wants to be part of developing those technologies, then engineering's probably for you.
All right, I'll jump in.
Oh, go ahead, David.
Or would you like to go first?
It doesn't matter.
Okay. I had an inkling that I wanted to be an engineer from the time I was really small. I literally would take my toys apart and try to put them back together and try to improve them somehow. I had a great uncle who liked electronics and was tinkering with electronics, and I wanted to learn from him and learned how to build a radio on a PCB and things like that. But then eventually I ended up doing something completely different. And for my undergrad, I went into humanities. I studied theology, of all things. But throughout my entire life, I continued having this desire to tinker with things, to learn things, to improve things. When I got my first computer, the first thing I did is I took it apart and learned what was inside, and then learned how to upgrade it and make it better, and ended up building networks. And I, put in a network in a school after college and things like that. But eventually, my life turned around a little bit, and I ended up switching from hardware to software and learn about the power of algorithms and how we can create new algorithms to solve really interesting problems. So I turned from computer hardware to computer software and algorithmic design, and that's where I am now, trying to solve interesting problems, which I'll tell you more about later. Thanks.
And I was just going to mimic what a couple of other people have said. I kind of had an idea I might want to be an engineer. I have a similar story to Dr. Anastasiou's, where I got in trouble very young for taking apart things that I shouldn't take apart. I remember once my parents caught me, I had taken apart our new VCR and I was popping capacitors off the circuit board. So yeah, I like to take things apart. Got me into a lot of trouble. But as a chemical engineer, I actually really sit at the intersection between science and engineering. And so I was very torn for a long time. And what I ended up really getting a passion for was sustainability and how we need to start thinking about some of these grand challenges in our world. And so that social impact was really important to me. And so because of that, I started doing more chemistry that is at the intersection of sustainability. That's why I'm a thermodynamicist. It has a lot of things with energy cycles. I did a lot of material separation. I tried to separate flue gas from the non-toxic fumes that come out of our coal-fired power plant. But ultimately, it was the impact that you could have as an engineer. We use the science that I could have done research in and stayed in, but then we actually get to apply it. And that's really what makes engineering really powerful, is that application.
So I would jump in. I look at the questions in the chat. It was amazing questions. So I will try to touch upon some of them in my few minutes. So I think I may be the kind of atypical engineering student. First of all, my math was really bad. So there's a question whether the math come naturally. I was really, really bad at math until grade 9. I actually failed some math classes before grade 9. And then there's a really good teacher who inspired me. So then I become really enjoying math and physics in my high school towards the end. So then I was I didn't like to take things apart. So I know many engineers like to build things and take things apart. But for me, I was more into the analytical side of the system. I like to analyze the system. So there are many kind of engineers. So I was thinking that I'm more the theoretical kind of engineers. And then, so I was actually going to go to do math or physics. But then when I go to an admission event at the university, then I got introduced to engineering. Then I saw a lot of math and physics in engineering as well. So, and I thought that, well, I can not only do just math and physics, but I can see how this abstract theory and concept got to do something real and tangible. I think that is, and have some immediate impact on society. So I think that's what got me interested in engineering. So I get to do the math and science that I wanted, which has some immediate impact. I think that is the thing that amazed me the most, that I want to do engineering instead of just simply physics and math. Yeah, I can talk more later on, but.
Dr. Pak, a quick follow-up question specifically for you is, someone is wondering if mechanical engineering is as versatile of a major as people say. What are your thoughts on that?
Yeah, I would say yes, because mechanical engineering is one of the oldest engineering discipline, and it's really very broad, one of the broadest, I would say. There are different kinds, because you need to study many kind of subjects, and then, for example, there was a question about design. What is the relationship between design? I would claim that every single product that you see involves some kind of product design or manufacturing. You need to make them, right? And that's where mechanical engineering will come into play, where you will need to design the manufacturing process, right? Like a simple, as like a bottle of water. How can you make these beautiful things? This is so smooth with all these pattern, right? We don't handmade this kind of thing. We actually build robotic systems. We build a manufacturing system to make this kind of nicely plastic bottles, right? So every single thing that you see, from a bottle to a car to aircraft, anything, you need to have some mechanical engineers involved into that, right? So that's one of the reasons why mechanical engineering is such a broad and versatile field. And mechanical engineers also collaborate with many other engineers, like civil engineers, right? Civil engineers will build the structures, and mechanical engineers will work with them to actually make a structure your home and your school, right? That you will enjoy spending time into it. Like the heating, ventilation, air conditioning, those are mechanical engineers work as well. And then mechanical engineers also work with electrical engineers, right, in power plants. So I did an engineering internship at a power plant. So it's really amazing how the two types of engineers work together to literally power the entire society, right? So mechanical engineers is more on the power generation part, how to use a turbine to actually generate the thermodynamics to generate electricity. So in the power industry, and also in many other areas like biomedical engineering. I think Katie mentioned prosthetics, right? So many engineers actually work with bioengineers as well to design robotic system for biomedical applications, right? So it is indeed a very versatile area, and we collaborate a lot with different kinds of engineers.
Yeah.
Let me just quickly follow up. We do that across the engineering school. In the electrical engineering department, we're working on robotics projects with the mechanical engineering department. We're working on networking projects with the computer science and engineering group. We're working on materials with the biomedical people. You have some flexibility. You're not putting yourself in a box as much by picking a particular discipline. A lot of our students work either as single majors or double majors across disciplines and with people in other disciplines, because that's the nature of the world today.
Yeah, I always tell students who are a little bit unsure about the field of engineering they want to go into, or if they want to go into engineering, think more about the problems you want to solve. Think more about the impact you want to have. Don't think about the major specifically, because almost every engineering major, if you have a BS in engineering of any type, you'll be able to follow that passion to what interests you, because it intersects a lot. So think more about the problem than the major.
There's somebody was just asking about what's the combination of biomedical engineering and computer science and engineering. We currently have projects in which we're designing different devices that can help either predict disease or cure disease that involve both computer science and biomedical engineering. I have a couple of those projects right now in which we're collaborating with people in biomedical engineering to design, for example, a device to detect kidney disease in patients, where the biomedical engineering side, that team is developing a test strip that changes color based on the amount of creatinine in blood. And then on our side, we're designing an application for a phone that can take a picture of that test strip and can tell you the severity of kidney disease through a lot of computer vision and machine learning algorithms. So those kinds of examples exist across the board. We have tons of collaboration with other parts of engineering, throughout all of the departments, basically.
I would like to jump in regarding their questions about biomedical. To complement what David just said, we also have what you call a bio AI track that combines specifically medical devices, test strips. Starting your third year, you could be working in a lab, learning how to program, starting machine learning with the biostatistics courses that we have. You can pick up some of these techniques, some of the projects that David was bringing up. Right now, they're moving very fast to the senior design level as well. So if you want to get, probably the product of David's research is much more sophisticated, but the curricula are changing very fast. So examples of kits, medical devices, we have this teaching in an independent research in the bio-AI track in bioengineering right now. I wanted to add on to that.
Yeah, thank you very much. And thank you for the faculty answering some questions in the chat, because you're all sending really good questions. One that we've gotten a few times that we want to cover is, how can an engineer help enact greater social change?
If I can, I'd like to jump in on that one. I didn't mention I'm the advisor for Engineers Without Borders and also Society of Women Engineers, which I love. You don't have to go through something like Engineers Without Borders, but my students actually work with communities that are highly impoverished and help get solutions, say clean water or mechanizing processes that they're doing to save them time, money, and whatnot. But our engineering solutions are the reason that you have clean water in the United States coming out of your tap is from engineers, and you don't have that around the world. They're going to be the ones that are solving the problems like in Flint, Michigan with their water, but also what's happened right now in the world with the riots and the reasons of the riots. I mean, it's not okay. But we wouldn't have even known if it wasn't for the cameras, right, that were there, which are designed by the engineers. So just being an ability for the general public to start saying, hey, this is happening and this is happening too often and we have evidence. So there are those opportunities. I know that when my building is safe from an earthquake, I have saved hundreds of lives potentially, depending on the size of the building. So I think across all the fields, of course, biomedical, it's very easy to say a single direct link, but we don't always think about that bigger picture of when we start connecting people and we start expanding the world and we start allowing for greater viewpoints to connect, also what we're doing for people and that ability for somebody in a rural area or somebody with lower income, if we can get infrastructure to them where they can connect and they can get online and they can get the same resources. It's not providing equity yet, but it is helping that step to get up to a place where they have equal opportunity. Not necessarily equity yet, but at least equal opportunity. And I think that's a joy of what we do.
And let me also just jump in. Santa Clara is the oldest engineering school in California, and you would ask, why is there an engineering school at a Jesuit institution? And you have to look at how it fits into the whole mission. The idea of engineering at Santa Clara is we are training people to make an impact on the world and to make the world a better place. And that's a theme throughout our entire program. And it not only impacts the range of classes that you take, but it heavily impacts the kinds of projects that our students work on.
Yeah, thank you for your answers. If you can believe it, we only have 10 minutes left of this Q&A, so I'm going to hand it over to Taryn to ask some of our frequently asked questions from the chat.
Yeah, so the first one that I think many people are asking is how easy is it to change engineering focuses, and kind of going off that, how can you figure out what path is right for you?
Can I jump really quick in on the path? I answered this in the chat way earlier. I mean, obviously we have Engineering 1, go Dr. Jack, which exposes you to all the fields, which is really great. But I really, really, really always encourage my students. I have so many that come in to ask me about the major, and I'll give them Discover Magazine, which is like National Geographic meant Scientific America and way more accessible than Scientific America. I tell them to go out and Google mechanical engineering projects, civil engineering projects, computer engineering projects, and to go through and keep a running list of, wow, I want to read more about that one, and write down the ones that excite you. But the ones you go, meh, doesn't sound interesting, write that down too. And then look for the patterns, because an engineering degree is a lot of work. And if you're excited about the topic, it makes it that much easier. So just go out and investigate. All of the areas have their own society chapters: American Society of Civil Engineers, American Society of Mechanical Engineers, IEEE, Institute of, is it Institute? Thank you, Katie, for nodding. Institute of Electrical Engineering. And they have all sorts of outreach material on their websites that explains what they do. So that's a great place too. And then it is easy to switch, but others can talk about that. So I'm not dominating.
And I was just going to mention too, there's a lot of websites. I think payscale.com is one of them that, you might go to if you're trying to find a price comparison for what you should be hired at, but it actually has a huge amount of power around the careers. And so if you search, say, mechanical engineering in payscale.com, not only would it tell you what they typically earn, but as you scroll down, they'll tell you how much you'll earn over time. They'll tell you the typical employers of mechanical engineering. They'll tell you how geography matters for where you're going to be hired, the types of projects you're going to work on. So there's all kinds of information out there if you know where to look, and you can always shoot us an email if you're not sure.
Okay, we can move slightly adjusting. Many are wondering, what are the different career opportunities within engineering, and how are they different than some of the other STEM majors in other fields?
So let me just jump in a little bit. I'm not sure I completely understand, but just to give you the scope. So I have not worked in engineering my whole career. Training as an engineer, learning how to analyze things, how to solve problems, has helped me do other things. So I actually worked for many, many years as a senior executive at companies. I am currently a director of a company that makes video game stuff that's public, but I spend a lot of my time working on audits and SEC compliance and other kinds of things, because I've learned quantitative skills, I've learned problem solving, I've learned analysis. I also worked in the legal field on intellectual property for many, many years. And you find many engineers who do all those things. Finance is another one. I haven't worked on it, but a lot of people do. So we have a lot of engineers who go into very traditional engineering roles. They're at a factory helping to design something, or they're at a design firm, or they're working in a software company. But we also have people who go on to a variety of things. We have students this year who are going on to law school. We have students who go to business school. And we have students who just jump into companies as engineers and then morph their careers in those different directions.
Okay, a very interesting question just came up. What would you say are the most important skills to have as an engineer?
Curiosity.
Enthusiasm.
I don't think there are a set of skills.
Like
It's
attention
so
to
broad.
detail, tenacity, willingness to try something new.
Mhm.
Desire to solve new, exciting problems.
Yeah,
I think of it like cooking. You get a recipe and you look at it and you say, that's good, but what can I do to make it better? That's an engineer.
And I will put a remark, because I don't think that it should be and. It's not that you need to have everything in order to be a good engineer, because there's so many types of engineers. So if you're interested in one of those skills, if you have one of those skills, you can be the kind of engineers that excel already. Yeah.
Well, and someone in the chat was like afraid they weren't creative enough, so how would they be an engineer? And the idea is that some people are these, what I call blue sky, can come up with these amazing ideas. I can't, you know, but they're not necessarily great at implementing. And then other people are super detail oriented and just want to check the boxes off. And it's like, I put those two together, bam, I just made an amazing thing. And in that question about science and careers, like the difference in the STEM, scientists discover new things. They spend their time in the lab looking to discover new ideas. Engineers take ideas and we make new things. And so it's a very different application of it. And so just deciding which side are you on? Are you on the more theoretical, but stuff doesn't come out of it? Or are you, but it's useful stuff, we build off of it later? Or are you the one that wants to say, okay, that's great, you discovered this, what do we do with it? How do we improve people's lives with that? And that's, I think, kind of the difference when you say the STEM fields.
And I think I would build off of that, because I think one of the really important skills engineers need is the ability to work in a team. And it's exactly what Dr. T is saying, where the power of a team is to do more than you can as an individual, right? Or as a group of individuals. And so if you have a creative person on your team, or if you have someone that's very good at detail, or someone that can see the big picture, like all of those are going to work together to make the product that much better. You're not stuck, you know, by yourself trying to come up with the world's most ingenious idea. You build off of each other. That's really the hub of creativity.
So another question that has been coming in a lot in many different forms is basically the idea of how can high schoolers prepare to study engineering or go into this, the level of university, and then prepare for their career? What should they be doing now?
One of the things you should do is take classes that challenge you, no matter what they are. Now, math and science classes are probably better. Somebody just asked the question, do you need to know software coding? No, we'll teach you software coding. But what you need to be able to do is approach hard problems, work on them hard enough to figure them out, know when and how to get help when you need help, know how to work with other people. I mean, one of the things that hasn't come up here is, you know, the most important part of learning as a starting off engineering student is talking to the other people in your class and learning from them, right? So you need to learn how to do that. You need how to learn how to work in groups, right? So look for those kinds of opportunities, and they don't all need to be in class. If there's if there are clubs or other kinds of things at school that help you to develop both thinking skills and soft skills, communicating and teamwork skills, those are all going to help you be successful in college and engineering.
And don't think that you have to have had calculus and have had physics to get accepted into engineering or to do well in engineering. Our valedictorians 8 years ago, civil engineering student, started in pre-calculus before the even calculus series. He wasn't prepared, and he ended up being the valedictorian at the university. So woo-hoo-hoo, right? But if you're willing to work hard and be humble and accept that, yeah, I got to learn this stuff, you're fine.
Yeah, and I would echo that. Just a willingness to learn is the most important part. And so working on hard problems while you're in high school is a key ingredient to that. But if you're willing to learn, you can learn almost anything. And we learn throughout our entire careers in engineering. The learning doesn't stop when you get out of school, right? Even if you learn how to code, like I learned how to code in Fortran. That's not often done anymore. But my background in Fortran helped me be able to do all kinds of other programming, right? I teach Arduino and I teach Python, right? Like it's just the willingness to learn. And then you see, you know, like it's the building bridges that learning is, that's really important.
Exactly, and it's okay to start at any level. We have some students that don't have any experience in coding and don't have very strong math skills initially that will start from scratch and build up. We have other students that do have good, strong coding skills and math skills as well. And what they can do is skip a few beginning classes, basically. So that's, to answer your question from earlier, what can you do? Wherever you are, identify your level and try to improve and try to learn new things along the way. But as my colleagues have mentioned before, It's all about your willingness to learn and your willingness to solve real world problems. That's the most important thing here.
Okay, so we're going to move on to one more last question here. And we're going to ask, many people have been wondering, how does Santa Clara and how do you as professors prepare students for the competitive job and career market that they're going to go into? So how can you prepare them for careers after?
Kind of a loaded question, but I think that what Santa Clara does really well is what we've touched on with that T model. It's not just the technical skills, it's being able to communicate those skills, work in teams, be a leader, do all those kinds of things. So the T model at Santa Clara is really powerful, I think. I'm an advisor for all the general students, the general engineering students, but also all the undeclared students. And in addition, I also advise capstone teams, right? And the skills that we're teaching throughout are all the same. They're all things like problem solving. But what we do work is we work very closely with the senior design teams. We work very closely with all of our project teams, making sure that they have skills that employers need. And honestly, some of the skills that employers want most are those communication, teamwork, some of those skills that we really build off of as part of our liberal arts history here at Santa Clara, and not just the technical skills. A lot of people can do the technical skills. It's making that whole person that's powerful.
And we'll run that. Go ahead.
No, sorry, Andrew. So another aspect that I want to touch on, a lot of our faculty are either working full-time in industry or have industrial experience. So that experience helps bridge the gap between academia and the expectation outside of academia. So that is a big advantage when you come to Santa Clara. And we are quite strict in terms of making sure that, as my other colleagues have elaborated, that you have the problem-solving skills and the team skills required in order to succeed outside. So I think, for example, we talked about capstone projects. One way that we prepare our students is we pretend to be judges, working from outside, an industrial judge. What are the engineering standards that are expected out of a project? What are the metrics that you're testing? If you were an intern at this company, a highly skilled technical intern, what are the questions and the skills that you're supposed to have while presenting this project? So I think this is one of the strengths of Santa Clara. We have a realistic eye also outside the campus.
And those are the most important things. We do a couple of other things as well. I know in our department, we take all of our freshmen out to visit 10 different big important companies, right? To have them talk to people there and understand what they do, how they work, what their expectations are. Places like the Google Moonshot Lab was one that we did this year, things like that. And then also, one of the things we continuously do is we go back and we look at our teaching programs, and we try to make sure that we're teaching you to use the kind of tools that you would use in industry so that you're familiar with them and you're skilled with them, ranging from SolidWorks in the mechanical engineering department or Synopsys in our chip design group. We're teaching you essentially in a way that if we were hiring you, we would expect you to work.
One of the other things too is, and one of the benefits at coming to Santa Clara University is that we have a focus on working with small classes. And because of that, you have access to faculty to not only work on interesting projects in classes, but to get involved in research. A lot of our faculty will work with undergraduate students in research projects and open up your imagination to being able to solve interesting new problems that maybe sometimes you wouldn't have even thought of before. And those are the kinds of things that will prepare you for the next steps. And also the output from that research or from those projects that you get involved with, even in your capstone project, will benefit on your resume as you apply to different companies. So that's, I think, one of the strong points of our university.
And one thing mechanical engineering department has done this year is try to strengthen the connection with the industry. So we have student organization who organize like an industry connection evening. So we invite professional engineers, hiring managers to come to Santa Clara to talk to our mechanical engineering students. So this is not like a general career fair, which could be very overwhelming and you don't get the chance to really interact with the speakers of the panel. But these are very targeted and we reserve a lot of time for students to ask questions to the practicing engineers, to make personal connections. So that may be good for them when they graduate and in terms of job employment as well.
Yes. All right. Dr. T, go ahead.
I was just going to very, very quickly say that one thing is, we say all of these things, but I want to let you know that I hear from employers all the time. Civil engineering has its own career fairs. Our students are when I go to the senior design conference and I'm talking to employers and alumni from across all the fields, what they always say is that I can hire an engineer from any school. I expect your students to have the basic engineering skill. You don't come out of college like ready to you come out with the base knowledge and then you start learning in engineering. So they expect that and you'll come out with that. But what they say is, the employers all say at Santa Clara, I know I can get someone that can communicate and can work on a team and has an ethical background. And that's huge for employers. So I want to say it's not just what we say, it's what, and we've never had civils. I'm like, we can't fill the need in our department from employers.
Yes.
Sorry.
No
for
worries.
computer science and engineering.
Yeah. I'm gonna have to cut you guys off there. That was really great. Thank you to all of you for all of your insights. If faculty, if you have the time in the next few minutes, especially to scroll through and look through the chat and maybe answer some last questions through there, that would be much appreciated, I'm sure, from the students. But now we're gonna go ahead and transition to our student panels. That'll take up the majority of the rest of the event, so please ask away when you get to those breakout rooms. But before we split up into breakout rooms, there's a few items on the to-do list. First, Taryn is going to throw some instructions in the chat. Please follow them and rename yourself by adding a letter to the beginning of your name so that we know which breakout panel you'd like to be a part of. And yeah, so now we will go into introducing all of our student panelists before we split up. So students, as I say your name, go ahead and tell us your year, major, and the panel that you'll be on. Starting with Layla.
Hi everyone, I am Layla Scola. I am currently a third year junior. I'm studying computer science and engineering, and I will be in the Women in Engineering panel.
Thank you, Layla. Bree?
Hi, I am Bree. I am a senior computer science and engineering major, and I'll be in the Women in Engineering panel.
Thank you, Bree. Taylor?
Hi, everyone. My name's Taylor Yamane. I'm a senior and a mechanical engineering major with an a minor in aerospace engineering, and I'll be in the Women in Engineering panel.
Thank you, Taylor. Julia?
Hi, my name is Julia Yockledge. I'm a first-year mechanical engineering major, and I'll also be in the Women in Engineering panel.
Thank you. Edith?
Hi, everyone. I'm Edith Gonzalez. I am a second year studying computer science and engineering, and I'll be in the first gen panel.
Thank you. Jaylene?
Hi, everyone. I'm Jaylene Solis. I'm a first year bioengineering major on the medical devices track, and I'm going to be in the first gen panel.
Thank you. Marieli?
Hi, everyone. My name is Marieli Rubio. I'm a third year civil engineering student, and I will be on the first gen panel today.
Thank you. Rodrigo?
What's up, everybody? My name is Rodrigo. I'm a sophomore at Santa Clara studying civil engineering with a minor in entrepreneurship, and I'll be doing the first gen panel.
Thank you. Mariela?
Hi, my name is Mariela Zuniga. I'm a second year electrical engineering student, and I'm going to be a part of the LGBTQ panel.
Thank you. Ardella? Is Ardella here? We'll come back. Maria?
Hi, I'm Maria, a second year bioengineering major, and I will be on the LGBTQ panel.
Thank you. Daniel?
Hi everyone, I'm Daniel.
Daniel
I'm a
Mendoza.
third year
I'm a
bio.
which Daniel?
Oh no. Sorry,
Okay,
Daniel.
I'll just finish. Hi everyone, I'm Daniel. I'm a third year bioengineering major with a minor in electrical engineering, and I'll be on the Men of Color panel.
Thanks, Daniel. Danny, go ahead.
Okay, yeah, I'm Danny Mendoza. I'm a junior electrical engineering major, and I'll be in the Men of Color panel with Daniel.
Thank you. Obasi?
Hi everyone, my name is Obasi Lewis. I'm a senior engineering physics major with computational emphasis, and I'll be in the Men of Color panel.
Thank you. Taryn, you introduced yourself, but do you want to let people know where you'll be?
Yeah, I'll be in the general panel, one of them.
Cool. Thank you. Catherine?
Yeah, I'm Catherine. I'm a third year computer engineer, and I'll be in the general panel as well.
Sarah?
Hey, I'm Sarah. I'm a junior. I'm a web design and engineering major, and I'll also be in the general panel.
Thanks, Sarah. Angie?
Yes, my name's Angie, or Angelus. I'm a second year computer engineer with a philosophy minor, and I'll also be in the general student panel.
Brian?
Hi everybody, my name is Brian Perez. I'm a first year bioengineering major, and I'm in the biomolecular track, and I'll also be in the general student panel.
Perfect. And just double checking, Ardella, are you here? Okay. SU students, if you guys could rename yourselves too, that might be helpful for Ricky, who's splitting us up. But yeah, so now you will all be sent to breakout panels very shortly. Have fun. We'll see you soon for some closing remarks. Welcome back, everyone. That was very stressful trying to answer like last questions in the last 5 minutes. Okay. I don't know if everyone's back, but I will assume yes, since it's 2 o'clock. Just a few closing remarks for everyone. Welcome back, first of all. I just want to take a moment to thank all of the incredible volunteers, staff, faculty, students. Thank you so much. Thank you to the high school students for joining us for our first ever virtual engineering seminar. There will be a follow-up email sent out that'll include all the information and resources from this event, a short feedback survey. It'll also include a PowerPoint of all the student volunteers from today and contact information in case you have any follow-up questions. We hope you learned a bit with us today. If you take one thing away, remember that as long as you like to solve problems, you are an engineer at heart. You're all very capable, and we wish you the best of luck in the next chapter of your lives. So that's all we have for you today. Thank you for coming. Stay safe and have a great summer. Goodbye, everyone.